what it is and what is expected from it, what are our development plans. Then I provide an overview on the calculation modules that will be developed and integrated to the platform. Then we present a use case for the COOLIFE Toolbox, and we finalize our presentation with a demonstration of the platform at its earliest stage. So the COOLIFE Toolbox is an interactive, user-friendly, and open-source tool. So saying that, we have used a large array of open-source tools for this development on the platform side, but also on the development of the calculation modules and also in providing the data sets. So everything from scratch has been developed with an open source license and will remain open source. The platform also provides possibility to visualize GIS data and has a special focus on the cooling related data sets. And as I mentioned, we will be able to run analysis on those open data sets and manipulate data and get new indicators and information out of them. So we have planned 3 releases for the platform. The very first one was in March, just last month. So we released for internal development a demo version of the platform where our calculation modules developer and also dataset providers can work with it and also integrate their datasets and calculation modules. And we have 2 additional releases, public releases. One will be in October 2024, where we will provide a complete infrastructure based on the identified user needs, which already Simon mentioned them, and also this version will be tested or have been already tested by our stakeholders, and we have already applied their needs. And there will be a final release in early 2025, where we will fine-tune all the functionalities in the platform and adapt according to the feedback that we receive from our users, and also through the workshops that will be held in the project. So here I would like to provide an overview of the capabilities and calculation modules that will be developed for the toolbox. Basically, by a calculation module in a COOLIFE context, we mean a programming tool that interacts with the user, takes several input parameters, uses available datasets in the database of the platform, and also GIS layers, and performs calculation on these inputs and input data sets and manipulates them and return useful indicators and new GIS layers. So it could be only the indicators or both indicators and also GIS layers visualizing the platform. And in that sense, we have planned 6 main calculation modules for the toolbox, starting with a space cooling demand, which first of all provides some generic information on a hectare level for coming years for visualization purposes, but also you can perform analysis for identifying the cooling needs, space cooling needs of building based on their archetypes and additional input parameters. We have a calculation module on technologies and measures, which was also partially introduced by Bruno. Calculation module on comfort, style, and user behavior. Economic feasibility calculation module, which also determines if it makes sense to go for a decentralized cooling supply option or to go for a centralized one, and also provides indicators, economic indicators on top. We have legal and regulatory layers, which are basically informative layers and are offered on a non-zero level, on a national level, combined with financial part which Julia earlier presented. There is also one calculation module on demand side management and demand response, which is basically RC modeling of the buildings and trying to provide measures for demand side management. And there is, of course, one additional calculation module which we're going to have it and will demonstrate today. It's district cooling potential assessment, where we identify potential areas for district cooling on a municipal level. This is the primary list. We may adapt the names and also their orders in the upcoming releases, but for the time being, it's what we will have. And if you have any question on a specific calculation module, please kindly add them in the chat. I try to come back to them. So for a use case of the COOLIFE toolbox, I can say that we can put those calculation modules in three pillars, so building level, and also local, regional level, and national level. And with that, one can start with identifying the space cooling demand on a building level, then say which technologies and niches are relevant for this building archetype and building, and of course it needs several input parameters for each of these steps. Going to the economic feasibility and the central option, providing indicators if it makes sense to have it as a decentral space cooling option or not. And demand side management, of course, provides best way to run this system. And as I mentioned beforehand, there is this district cooling potential assessment module, which works on a local and regional level, not on a building level, and it provides the suitable areas within a municipality, for example. There are some informative layers like demand layers as potential layers and climate data layers, which are also provided on a local and regional level. And on national level, we have those two calculation models on comfort, lifestyle, and user behavior, as well as legal and regulatory layers. Saying this, I will continue to our demo of the toolbox. And I hope that everything goes well in this demonstration. Of course, it's a version which has been developed and put online for our internal use and development purposes. And I know colleagues always do development, so maybe something crashes, but let's hope that everything goes well. So basically, once you open the platform, you get a disclaimer page where we have some information for you there, where you can see where the codes are available, and you can clone the repositories and do further development on them, or you can check where the datasets are stored. And once you accept this disclaimer, it will not appear anymore, to not buzz you anymore, and that should be only seen for the first time. The platform itself composed of a menu on top where you have several options for searching a place or directly navigating to the COOLIFE website, but also you can create a user account And once you get into user account, you can also upload your data sets and visualize them. So I can just show mine. Then we have some menus where we can have different geographical borders on the map, and depending on which level we are, the functionalities offered by the platform are different. For example, on a hectare level, we don't see borders, but we can do specific custom selections for special regions that you are interested in. And the indicators provided will be calculated on the fly. And also, calculation modules may be called may give permission to be run for one or the other boundary level that you select. Then we have a tools window where you can see basically your previous upload. So if I go to one of my previous selections, so if I don't want to select the regions every time there are large number of regions, I can use this pre-selection, and also if I have one additional region, I can also save it as a new name, so I can give a new name to that. And next time that I'm opening the platform and I want to quickly go to the region that I was interested in, and also with the set of layers that I selected, then I can click on it and then quickly navigate to this region. On top, we have additional functionalities very similar to Outmap platforms, where you can just select a region or make a free selection, or even you have the option to upload a GeoJSON layer if you want to be very precise with the borders of the region you want to work with. You can of course upload a GeoJSON file to your user account, and then your selection will be very accurate. Once you log into your platform, you also see a new menu which is called Files, and under these files, everyone has 500 megabytes of space. And you can upload your data sets there. Here I have one data set for the city of Vienna, but you can also upload your layers of interest. And then in the layer tabs, you can see personal layers, which are basically in your user account. So if I log out, I don't see them anymore. You have the option to share this data set. So if I select this one, I can also share it with people who have account on the platform and are from my company. So basically, if it is at turing.ac.at as the domain of my email address, anyone else, if I share it, then anyone else with this domain address would have access to this data set. We have a bunch of layers on the platform. It's not limited only to the cooling, but also heating, because we think there might be a synergy between heating and cooling, and it's always good to have them both on the platform. And some of these data sets will be updated in upcoming months before our release. For example, in terms of cooling density, we have so far a default data set for 2015, but this will be updated, and also we will have layers for 2030 and 2050, which shows the theoretical cooling needs on a regional level. Of course, not very accurate when you zoom into the hectare level, since it's a theoretical cooling need, but it should be seen as an indicator. There are the cooling spots and where do we have higher space cooling needs. Additional layers are like gross flow area, share of gross flow area from different construction periods, geothermal potential, heat conductivity, and climate category. We have average temperature, cooling degree days, heating degree days, solar radiations, and also wind speed. So these are the layers on the platform. And the next part is basically the indicator tab, which you see basically when you select the layer, and then you also select the region. Let's say I go again to Vienna and select Vienna. It has already shown that I have selected only one region, so if I select additional regions, this number will change. And then you can always load the results and see some basic indicators for the layer selected, or also from your personal layers. And as you select additional layers, these indicators will get updated and additional information will be added as well here. On a layer side, we also have the option to download the layers directly, so you can, if you don't select any region, the fourth symbol will disappear, but if you select the region, then you see this sign as well, which means that you can download the dataset for the selection that you have on the map. You can download the whole datasets. You can go to the repository of this dataset to see more information, go through the README file, the source of information for this data and where it comes from, under which license and so on. And also the layer legend is shown underneath of each layer for information purposes. So far we have like these categories of the layers on the platform. There would be like one additional category when you run a calculation module, and this calculation module returns one layer. We will have one additional category which is called the calculation module layers. So the outputs of the calculation modules will be listed here and can be downloaded afterwards as well. With this, I would go to the calculation module tab. So far, we have only one calculation module, district cooling, and I asked my colleague Adit to give a short brief presentation of this calculation module and how it works.
Yes. Yeah, thank you, Mustafa. Yeah, so I will just give you an overview on the district cooling calculation module, which is basically a calculation module designed to perform a first-level economic assessment of district cooling potential in any given region. And as Mustafa said, there are different levels on which the platform can be run, but the calculation module itself, it runs on either a Lav2 region or a hectare level. Yeah, we just consider your region because the district cooling itself is something that's a very local infrastructure. So in that sense, we try to assess potentials, let's say in a given city. So for this demonstration, since we're here, I choose Vienna as our case for running the model. And so going into the district cooling calculation module, on the left side, you can see the description of the calculation module and all the input parameters the model takes to identify potential locations for district cooling. So firstly, to begin with, maybe I go to the layers again. And what this calculation module takes into consideration for calculating the potential locations are the cooling demand density layer, which is on a hectare resolution. So on a 100 by 100 meter raster cell, it identifies theoretical useful energy demand for cooling in the city. And another layer it takes into account are the gross floor area, which is the floor distribution, again on the same resolution. And also we take into consideration the non-residential cluster area, because for a district cooling network, it is quite pivotal to have also include non-residential space cooling demands, considering these are more highly consistent compared to residential sector, at least as of now. So with these three layers, we can finally go into the calculation module again and try to run this. So first of all, it gives us a session name. So by default, it gives the time of the run when the calculation module is being run. Also, the user can change the name as per input. Yeah, we can something. Yeah, thank you. And also there's the description, and also this leads to the wiki page, which provides more detailed description on the calculation methodology of the calculation module. And coming to the inputs, so how this calculation module basically works, it takes into first the most important parameter it takes into account is the average electricity price. So what the model is doing is at a given electricity price and under certain operating conditions of district cooling network, it tries to identify for every given hectare cell if it is feasible to either have a district cooling network for this particular location, or rather it makes economically more sense to have an individual or decentral supply. So, for instance, if we take a default value of 150 kilowatt hour per euros per megawatt hour, and then we also have inputs on the number of cooling days in a year. So, yeah, based on our experience of local Vienna, I think this is a default number that fits. But maybe if you're running it for another region, then you probably have to change it. And then we also provide the possibility of changing inputs on the performance and efficiency of the decentral and corresponding individual supply, as well as the district cooling supply, and also potentially on working playing around with the network operating conditions. So basically the density of the supply and return temperature of the pipes, and see how this would influence potential locations. And yeah, also on the individual side, and also some financial parameters can be changed or played around with users. So for instance, the interest rate, the depreciation times, and this is how the economics are calculated. And as I mentioned, the user is asked to get three different layers for the calculation module. So one is the cooling demand density layer, the other the floor area, and the other non-residential floor area. So when we run this model, depending on also on the size of the location, so being allowed to be a nice quite big, so this might take some time to run. But basically, what the model does is first identify locations where there are high non-residential gross floor areas, and then trying to replicate the properties of an ideal district cooling network. It sees to what extent it is feasible to expand the network and obtain the highest possible coverage. And yes, the model ran here, and this kind of gives us firstly a shapefile and different raster layers where district cooling could show potential feasibility. So the model is not telling us it is district cooling should be constructed here, but rather it provides locations where further detailed assessment and detailed network design can be performed. So this is the location, and if you see the results here, you can see, so this was the default layers, but also provides, for instance, the results of the calculation module. So theoretically, there was about 5.58 terawatt hours of demand in Vienna, of which about 60% can be economically fulfilled by district cooling based on the model results, but also there could be other constraints apart from the economics which could impact. But in general, there is possibility to cover up almost 60%. And also, the calculation module provides charts. For instance, here it gives the coverage and what amount of energy can be supplied from district cooling. And on top of that, as Mustafa mentioned, we go back to the layers, and now you can see here an additional category called calculation module has been generated. And here we have different layers which calculation module created. And so basically there are layers which provides the levelized cost of cooling for providing district cooling in this particular region. So I mean, in the figure you might see like one big cluster, but if you zoom in, probably these are like small networks which could be operated independently and also provides, let's say, average network lengths and pipe diameter needed for these regions, which can all be downloaded, of course. And if a user is willing to do some detailed assessment, then maybe these layers can be used as for the starting point for detailed analysis of the of district cooling potential, and also there is this shapefile which provides further details on potential locations. So this is one calculation module that we've integrated, and yeah, also from hand over to you, or
Yes, thanks, Adit, for your presentation. Just add one small point on that. As you can see here, you may want to run the code again, the module again and again. So in that sense, the timestamp or the session, the name will be handy to look at always and track them. Yeah, with that, I think we almost used the whole time of our presentation. I would be happy to answer your questions, also questions to Adit on the calculation module. Otherwise, we will keep you, of course, posted about the tool development as soon as we have the public version. Thank you.
Thank you. Are there any questions addressed to Adit or Mustafa here? There is no question so far.
Okay, great. Then I stop sharing my screen.